You're welcome to this channel. We are looking at the part 2, okay, of velocity time graph, acceleration time graph, and position time graph for AX and A level. This is M1 mechanics. Okay. Today we are going to continue with solving questions, okay, on position time graph, acceleration time graph, velocity time graph, the update of this channel. We're going to say as you are coming in. The first thing we want to look into, let's look at what we have here. You can see we have this has been sketched for us, okay, and the image we have here, the picture we have here, this is the description of this diagram, okay. We are told that the diagram shows speed time graph of the motion of an object riding along a straight road. She accelerates uniformly from rest to 8 meters per second in 20 seconds. And you can see the description. There is an acceleration from rest. Okay, this is the position of your acceleration. Okay, from rest for 20 seconds. And then the speed attained for that motion is 8 meters per second. Okay, she then travels at a constant speed, okay, of 8 meters per second for 40 seconds. Okay, she maintained the speed, that's why we call it the constant speed. The speed is being maintained, the speed of 8 meters per second is maintained for what? For 40 seconds. For 40 seconds. So what you do is that 40 plus the first 20, that will give you 60. That 40 is the interval from here to here. That 40 is the interval from here to here. Okay? So then, is when the body is coming to rest. And this is the place, okay? Decelerate uniformly to rest. Okay? Decelerate uniformly to rest in 15 seconds. In 15 seconds. So what you're going to do, you're going to add your 15 plus the last time plus the 60, making what? Making 75. So 75 is the total time from the beginning to what? To the end. That's the total time consumed for that motion. Okay? And then find the acceleration of the cyclist in the first 20 seconds. The acceleration of the cyclist in the first 20 seconds of the motion. Okay, that's the deceleration of the cyclist in the last 15 seconds of the motion. And finally, the total distance travel in 75 seconds. Okay, and I want to tell you, if you are looking for acceleration is just from is here. Acceleration is here. Is this place. Okay, the first triangle will give you acceleration. The last triangle, when you come to rest, will give you your deceleration or retardation. Okay, acceleration definition is changing velocity over time. Acceleration is changing velocity over time, which means final velocity minus initial velocity over time. Okay, the body starts from the beginning here. Okay, until you get to this place, and the speed attained is what? Is 8 meters per second. This is your acceleration. That's the place you can get your acceleration. Okay, so the difference here, this is the final, this is the initial. So 8 minus 0, changing velocity, and then the time is what? Is 20 seconds, and that's 8 over 20, which is equal to what? 4 over 10, which is equal to 0.4 meter per seconds square. Okay, so, and again, when you have your speed time graph, you must have your speed on the vertical, your time on the horizontal. In this question, the diagram has been drawn for us. The diagram has been given. Okay, all this story is just what it's just a picture of what has been drawn for us. Okay, the second one we are told to find the deceleration of the cyclist in the last 15 seconds. Body is coming to rest. So that will be equal to what? Deceleration is negative acceleration. Okay, the same formula, but we expect. So I'm using A for deceleration. Okay, but when you are talking of deceleration, we expect your acceleration, the value to be negative. Okay, the value must be negative when you're talking about the acceleration, and that's what final minus initial over what? Over time. Final minus initial over time. When the body comes to rest, the final is 0. Okay, your final is 0. The initial will be what? Will be this. Initial will be this 8 meter per seconds, and the time is from here. The time interval from 60 to 75. Even in the question, we are told that it spent 15 seconds to come to rest. So that's what? About 15. Okay, that's minus 8 over 15. Just need a calculator in this place to get the answer. When you are looking for total distance, okay, what you do is to check the geometry, check the shape, check the given shape. Okay, if you look at this shape, this is the trapezium. Okay, and the formula for trapezium, distance is what? The distance of what? The geometry of this shape. This is trapezium, and the formula for trapezium is half times A plus what? Plus B times what? Times H. The A plus B are the two parallel sides. Two parallel sides. This is one parallel side. This is another one from here to here. That's another parallel side. So it's going to be half times from here to here. That's the 40. The interval from here to here, that's 40. 60 minus 20, that's 40. Plus the interval from the beginning to the end, that's 75. That is the two parallel sides. That's the two parallel sides of the trapezium. And then times what? Times from here to here. That's the height. Or from here to here. That is the height. Don't forget these two parallel lines. They are equal. Opposite side of rectangles are equal to each other. So that is what? That is 8. Okay, that's what we get in that place. Then we can. This will be equal to 2 here 1, 2 here 4. So we're having 4. We're having 4 times 115. 4 times 115. Okay, 4 times 115. So that's so 4 times 115. So that's 460 meter. That's a 460 meter for the total distance travel. Okay, and if you don't want to do it in this way, you can begin to give. You can call this one distance for this one. This is a triangle. Call it x1. Call this one 2. Call this one 3. And begin to use the geometry. The geometry of this one is triangle. Get the area of triangle. Get the area of rectangle. Get the area of the triangle, and now add it together. It will give you this 460 also. Okay. Can we do that? Can we do that? Let's do that for that one. My one is a half base times height. This one is half base times height. This is my base. That is a half times 20. Half times 20. The height is from here to here. That's 8. And then plus. This is a rectangle. That will be L. That will be what? The area will be what? Area will be L B. Length times width. The length here is 40. That's 40 times the breadth or the width is from here to here. That's 8 plus the last one is also triangle, which is what? Half base times height. Your base is from here to here. 75 minus 60, that's 15. Okay, half times 15, and then the height is what? From here to here. That's what? That's 8. Okay, so the first one here will give you 80. That will be 80 plus 40 times 8, that's 320. And then plus the last one, 2 here, 1, 2, that's 4. That's 60. So add it together. That's 460. So the choice is yours. You can use the area of individual shape, okay, and add them together, or you use straight away the trapezium, area of trapezium, to get the total distance. So that's that on this question. Question still continue. We'll go to next question. If you're just coming in, just make it to say I. If this is your first time, subscribe to the channel and share the link of this video. Share the links of this video and give the videos a thumbs up. Motorcyclists start from rest at a point X on a straight raised track. Okay, it moves with a constant acceleration for 15 seconds, reaching a speed of 30 meters per second. Let's do that. Okay, let's go on. It then travels at a constant speed of 30 meters per second for 3 seconds. Finally, it decelerates at a constant rate, coming to rest at the point F 25 seconds after it begins to decelerate. Sketch a speed time graph to illustrate the motion. Given that the distance between X, S, and F is 2.4, calculate the time the motorcyclists take to travel from X to F. So what we do, let's quickly sketch the velocity time graph. So this will be your velocity on the vertical, your speed on the vertical, and this will be your time on the horizontal. That's your time on the horizontal. Okay, we are told it moves with constant acceleration for 15 seconds. Acceleration will be here. Acceleration is here. Okay, for 15 seconds. That's 15 seconds. Okay, it moves for 15 seconds, reaching a speed of 30. Reaching a speed of 30. Put your 30 there. Okay, it then travels at a constant speed of 30 for 3 seconds. So it maintains the speed. The speed is constant for 3 seconds. Okay, so that means this 15 is from here to here. The 15 seconds is from here to here. 3 seconds is from here to here. Okay, this is the origin. And finally, it decelerates at a constant rate, coming to rest at a point F, 25 seconds. Okay, so that is the piece. You can extend this one. So it's coming to rest. Okay, that means from here to here. That's 25. That's a 25. Okay, so that's what we have there, and that is the A part. Sketch the velocity time graph. So this is your acceleration. Yeah, this is your acceleration. This is your A in meter per second square. Okay, then we are told to calculate the time. This place. If you check the question, we are told that, okay, motorcyclists start from rest at a point X. So this is the point X. That's the starting point. That's the traveling point until you go to what? Get to point. This is point F. That's the point F. That's the point F. This is F. This is what, this is this place is what is point X. And the distance between these 2 points, the distance between these 2 points is what? Is 2.4 kilometer. That's the distance between the 2 points, 2.4. Okay, so we're going to use that distance because we are told to calculate this this t. So we're going to use this distance 2.4. That's the total distance from here, from the starting point to the end point. So 2.4 kilometer, which is 2,400, which is 2,400. And then the area of this shape is trapezium. That will be half times sum of the 2 parallel lines here, from here to here. That's a t, and then plus from this place to this place, from point X, S to F. Let's do that. That'll be 15. That'll be 15 plus that t, and then plus 25. Okay. Let me adjust that. 2,400 equal to 1, 2. Okay. Here, that's t plus from here to here, that's 15 plus t, and then plus what? Plus 25. And then times the height from here to here, times 30. So we're going to have 2,400 equal to half times, this will give me 2t plus 40 times 30. 15 plus 25, that's 40. So we are going to have 2,400 equal to half 2 here 1, 2 here 15. So we are having 15 times 2t plus 40. 15 times 2t plus 40. So we're going to have 2,400 equal to 15 times 2t, that's 30 t. 15 times 40 calculator, let's do that. Make t the subject, 30t equal to 24 minus 600, that's 18. So t is equal to what? 0 cancels 0. So we have 60 seconds for that time. If you're just coming in, please begin to say I, share the link of this video across your different platform. Okay, share, like, okay, and give the video a thumbs up. Okay, like the video, share, and what? And subscribe. If you're yet to subscribe, please do so right now. Okay, a train is traveling along a straight track to obey for 30 seconds. Okay, to obey a speed restriction, the brakes of the train are applied for 30 seconds. Okay, reducing the speed of the train from 40 to what? To 16. You can see when you apply the brake, the speed is reduced from 40 to 16. Okay, the train then continues. The train then continue. You can see the continuation. It then continue at a constant speed of 16 meters per second for further 70 seconds. For further 70 seconds. So 70 plus 10, that will give us what? That will give us 100. That will give us 100. That will give us 100. The diagram shows a speed time graph illustrating the motion of the train for the total period of 100 seconds. Find A, the retardation of the train in the first 30 seconds. B, the total distance traveled by the train in 100 seconds. Okay, without wasting time, let's go to solution. The retardation, we're going to use this formula, acceleration is change in velocity over time, which is what? Final minus u minus initial velocity over time. Final velocity minus initial velocity over time. Okay, if you look at the motion, the train started at 40. It started at 40, okay, and then there is a reduction from 40 to 16. So this is initial, this is a final velocity. So the final velocity is 16, the initial is what? Is 40, okay, over what? The time is what? 30. So that will give us what? That will give us minus 24 over 30, okay, and that will be equal to 6 here 4, 6 here 5, which is equal to what? 0.8 meter per second square. And don't forget the minus here, so the answer is minus 0.8 meter per second square. The distance will be equal to, if you label this one, let me call this one A, B, C, D. That's the rectangle. Okay, that's the rectangle, and that will be equal to what? From here, that's the length, which is 100, times what? Times the width from here to here. BD, that's 16. Then plus this place is a triangle, which will be equal to what? Half base. The base is from here to here, which would be this place, because it's rectangle. So that will be 30. That will be 30 for the base, and then the height will be from here to here, from here to here for that triangle. That's 24. That's 24. So this will be 1600 plus. This will be 15. 2 here, 1, 2 here, 15. 15 times 24. 24 times 15. So punch your calculator and get the answer. So that's that on that question. That's that on that question. That's that on that question. So we're going to have 1,900, 1,960 meter, 1,960 meter. Okay, 1,960 meter. So that's that on this. Just take your, call this one point A, B, C, D. That's rectangle. Okay, just find the area of rectangle plus the triangle. Okay, plus the triangle. So, or you can consider this one as trapezium, and then plus what? Rectangle. The choice is yours. Yeah, question 5. We have a particle moves along a straight line. A particle moves along a straight line. The particle accelerates from rest to a speed of 10 meters per second in 15 seconds. So let's quickly do that. Don't forget, we are told to sketch a speed time graph. So for speed time graph, we're going to have the velocity on the vertical. Okay, velocity on the vertical, velocity on the vertical, and then the time on the horizontal. Velocity on the vertical and the time on the horizontal. So velocity on the vertical and the time on the horizontal. Okay. The particle accelerates from rest to a speed of 10 meters per second. This is the place of acceleration from rest. That's the acceleration in meter per second square. To a speed of 10 meters per second in 15 seconds. In 15 seconds is my 15. The particle then moves at a constant speed of 10 meters per second for a period of time. The particle maintains the speed of 10 for a period of time, which we don't know yet. Okay, which we don't know yet. That's that. We don't know that place. The particle then decelerates uniformly. It decelerates uniformly. Okay. The period of time for which the particle is traveling at a constant speed is 4 times the period of time for which it is what? Accelerating. So let's assume this will be t. Okay, this place will be what? 4 times. From here to here is 15. From here to here is 15 seconds. Y from here to here is 40. And that's a 40. That's a 40. Okay, that's a 40. Again, the particle, the period of time for which the particle is traveling, for which the particle is traveling at the constant speed is 4 times. Here, the time is what? 4 times. Okay, the time to decelerate, okay, is 4 times the period of time for which it is what? Decelerating. So this will be 40. This will be t. Okay. Then sketch the speed time graph to illustrate the motion of the particle. So this is done. That's done. Given that the total distance traveled by the particle is 480 meters. Okay, the total distance is 480. Find the total time for which the particle is moving. Total distance, go to your geometric, go to the shape. This is a trapezium, which is a half times the 2 parallel side. Here is a 40 plus. From here, another parallel side, from here to here, which is a 15 plus 40, and then plus what? Plus t. Okay, and then times the height from here to here, that's a 10. Okay, so that will be 480 times 1/2, 40. Open this bracket, 40 plus 40 plus t, making 90, and then plus 15 times what? Times 10. Okay, so 2 here 1, 2 here 5. So we're having 480 equal to what? Equal to 90 plus 15 times 5, and that will be 480 equal to, that will be equal to 480 equal to, open the bracket, 5 times 90, that's 45t, plus 15 times 5, 15 times 5, that's 75. Okay, so 480 minus 75, 480 minus 75 over 45. That's your t. That's the t. Okay, 480 minus, that's 405. T is 405 over 45. Calculator, t is 9. Okay, t is 9. T is 9. So the total time taken, the total time for which the particle is moving will be 15 plus 4 times 9, and then plus 9 again. So that will be 15 plus 4 times 9, and then plus 9. So this is 36. 36 plus 15. That's 51 plus 9. That's 60 seconds. So that's the total time for which the particle is moving. And then before we can do the for the C parts, before we can do the sketching, we need to get the acceleration, y accelerating, when it's accelerating. Let's get the acceleration, which is at this place, the first stage, and that will be equal to what? A equal to theta v over t, and that's at 10 over 15. That's at 10 over 15. The first stage, when it's accelerating, change in velocity is 10, time is what? 15. and that will be equal to 2/3. That will be 2/3 meter per second squared. Okay. Also get y decelerating. Y decelerating. Let's get that. Acceleration will be equal to what? Y decelerating. Come to the last page. Okay, which will be equal to the final velocity is 0 minus 10. Minus 10. Okay, over from here to here. That's we got 9. We got 9 over 9 over 9. So minus yeah, that's minus 9 over 9. So y decelerating, we have minus 10 over 9 meter per second squared. Then we can now begin to sketch now. So let's begin to sketch the acceleration time graph. Begin to sketch the acceleration time graph. Yeah, begin to sketch your acceleration time graph. Okay. So this will be acceleration on the vertical in meter per second square, and this will be the time. So let's see how it look like. This is the time in seconds. So when it's accelerating 2/3, when it's accelerating, let's just pick a portion here. When it's accelerating here, so that's the 2/3. When it's accelerating, so that's the place, and we have the time for 15. We have the time for 15 seconds. Put your 15 there. It's accelerating. Okay, but here, if we check here from this is 15 to this point. Okay, from 15 to 36. From 15 to 36, 4 times 9, that's 36. So from 15 to 36, there is no acceleration. No acceleration in that place. Acceleration is at 0. You can just tick this place. There is no acceleration. No acceleration. This place. No acceleration. Acceleration is 0 from 15 to this is 15. This is 15. This 36. The interval here is 36. So 15 plus 36, that's a 51. So this place is a 51 seconds. That's a 51. Okay. Then after that, that's where we now have the what? We now have the deceleration time. We have the deceleration after that time. So, and that's what? That's minus 10 over 9. Minus 10 over 9 from this is 51 from here. This is 51. 51 to 51 plus 9. So this is 60. That's 60. Okay. So we just go down from here. Come down here. Okay. Stop at any place. This is your you can trace this place. This is your minus 10 over 9. Minus 10 over 9. And then this is what? This is your 60. This is your 60 seconds. Okay. This is your 60 seconds. And if you like, you can still move this one down if you like. Okay. So that's what we have in that. So that's the acceleration. That's acceleration time graph. That's that on the acceleration time graph. If you're yet to subscribe, please do so now and begin to share the links of this video across your different platforms. I want to, at this point, I want to say thank you for those that have come online. Thank you for those that subscribe. Thank you for sharing. Thank you for sharing the link of this video across your different platforms. Thank you for staying by to the end of this episode. Thank you, thank you, thank you. We are yet to like. We are yet to give the videos a thumbs up. Do that now. We are yet to subscribe. Do that now. We are yet to share the video. Begin to do that right now. Okay. Thank you. The video still continue. And the next an hour, hopefully I will come again for another episode. Okay. for another episode, hopefully. Okay, see you. Thank you. Bye bye.